In this video, we will be discussing about max sum of a pair with equal sum of digits. You are given a zero-indexed array nums consisting of positive integers. You can choose two indices I and j such that I is not equals to j and the sum of the digits of the number nums of I is equal to that of nums of j. Return the maximum value of nums of I plus nums of j that you can obtain over all possible indices I and j that satisfy the conditions. So what they are saying is that in the input, we are given an integer array nums. Now from this array, we need to select two indices I and j. These two have to be different such that the sum of their digits is equal, right? So if I write the sum of digits of all these numbers, so for 18 it will be 9, for 43 it will be 7, for 36 again 9, for 13 it will be 4, and for 7 it will be 7. So these are the sum of digits of all these numbers. Now we need to select two indices I and j such that the sum of their digits is equal, that is these are equal, and then we need to find the maximum possible value of nums of I plus nums of j, and this maximum possible value we need to return as our answer. So if we see over here, if we look at this particular element and this particular element, then the sum of their digits is equal, so they can be paired together, right? So we will do 18 plus 36. Then if we look at this 7 and 7, so these can be paired together, so it will be 43 plus 7. Now this 4 cannot be paired with any of the number, so these are the only two possible pairs that we have, and out of them this will give us the maximum sum. So this sum will be 54 and this will be 50. So this 54 will be our answer in this particular case. Then if we look at the second example, so here the sum of digits will be 1, 3, 10 and 5. Now here we do not have any two indices which are having their digit sum as equal. So here we won't be able to form any pair. So in this particular case, our answer will be -1. So now how to solve this? So what should be the brute force approach? The brute force approach can be that you try each and every possible pair, right? Firstly, you can store that what is the digit sum for each of the number in some array, and then you can start iterating in the nums array. First, you will run a for loop of I starting from 0 till n, and then you can run a for loop of j starting from I plus 1 till n. And then you can check that if the digit sum of I and j is equal. In that case, in some maxi variable, you can take the maximum of sum of the values at these two indices, right? These things, the digit sum, either you can take it in some array by doing pre-processing. Otherwise, you can calculate the sum of digits on the fly itself. Why? Because see, in the constraints, the maximum number that is given to us is 10 to the power 9. This have max 10 digits, right? And how do we calculate the sum of digits? So basically, if we have the number 18, what do we do is that first we do its modulo with 10, so we get the last digit, which is 8. So in our sum, we add this 8, and then we do 18 divided by 10, so the number left is 1. Then again we do the modulo of 1 with 10, so we get a 1. So we add a 1 over here, so sum becomes 9, and then 1 divided by 10 gives us a 0. So when the number becomes 0, we stop. So this is how we get the sum. So basically, we run a for loop for each of the digit in the number, right? The maximum digits that we can have is 10. So for finding out the sum of digits of a particular number, the time complexity that it will take is order of 10, which we can consider as constant, right? So if we want to optimize the space, then we can calculate the sum of digits on the fly, right? But here, since you would be running a for loop of I and j, a nested for loop, so time complexity will be n square, right? Although space complexity is constant, but time complexity is n square, which won't work, right? So let's think of some other solution. So if, let me add two more numbers over here. Let's suppose 54 and then 61. So now here it will be 9 and here it will be 7. So if you see these elements, their digit sum is equal. So they can be paired together, right? If I write them somewhere that for 9, basically, what are all the elements whose digit sum is 9? So that is 18, 36, and 54. Then for 7, it is 43, 7, and 61. And then for 4, it is 13. Right. So if I store this information in some hash map where the key denotes the digit sum and the values denote what all numbers are there whose digit sum is equal to this key, then what we can simply do, we can identify that what will be the maximum sum that I will get out of all these elements. So see, when we want to try to maximize the sum of two numbers, if I'm doing a plus b and I want to maximize this sum, So I will try to take A and B as max as possible, right? So for 9 out of these three elements, if we take the maximum element and the second maximum element, then I will be able to get the maximum sum that I can get out of all these elements, right? So what we can do is either we can sort this, right? If we sort this and we take the last and the second last element, then also we will be able to get our answer. Or if we do not want to sort it, because sorting will take n log n time, right? So if we do not want to sort it, then we can just iterate once in this and we can keep the track of the maximum and the second maximum number. So here it will be order of n, right? So this thing we can follow for all the elements. So here it will be 36 plus 54. These are the largest and the second largest element. Here it will be 43 plus 61, and here it has only one element, so it cannot be paired with any other. So here we won't take anything, right? And then we can take the maximum. Basically we can track the maximum sum that we have got, and at the end we can return it, right? So this is one of the approach that we can follow, but we can make it much more better. How? Instead of storing all the elements, we can always store that for this 9, for digit sum 9, what is the maximum element that I have encountered so far? Only that I will store in the hash map. So basically what I am saying is, so when we start with the first element, we see, okay, its digit sum is 9. So we go to the hash map and we see that corresponding to 9 is something present or not. So right now nothing is present. So what we'll simply do, we will update it. We will update the key as 9 and in the value we will store 18. Then we will go to the next element. Here the sum is 7. Again, key 7 is not present, so we'll just update it. Key will be 7, value will be 43. Now the next element is 36, whose digit sum is 9. Now if we look at the hash map, for 9 we have some entry, right? Corresponding to that 18 is present. Now this 18 and this 36 might give us the maximum sum, right? So what we will do is that in our maxi variable, we can track the maximum of maxi, comma, 18 plus 36. Basically, this will be your nums of 5, whatever is the current number, and this will be the, in the map, whatever is present at the key sum. Basically, we will do the sum of these two and we will track the maximum sum, right? So here it will be 18 plus 36. So 18 plus 36 we will keep here, and then in the map we will update this element to the maximum of 18 and 36. So 36 is greater, so this will be updated to 36. Why we are doing it? So that later on when we encounter some other element whose digit sum is 9, we can do the sum of this element which was the maximum till now, right? So now when you will come here, so it is 4, we do not have any entry, so we will make it. Then we'll come here, it is 7, we already have some entry, so we'll do the sum of 43 plus 7 and we'll keep the track of maximum sum that we have got, right? And then we will update it to the maximum of 43 comma 7. 43 is already greater, so it will remain as is. Then we have 9 over here, and here we have 36, so we will do 36 plus 54, and then this will be updated to 54. Then we'll come here, so here we will do 43 plus 61, so 43 plus 61, and then this will be updated to 61. And here we will always keep the track of the maximum sum, so at the end whatever is the maximum sum, that we will return. So this is the approach that we will follow. Now let's look at the code. So first of all, we will take an integer variable result in which we will store our answer, and we will initialize it with -1, because when we are not able to form any pairs, we need to return a -1. Then we will take an unordered map, right? The key will be integer and the value will also be an integer. Let's name it MP. And then we will start iterating for each and every element in the nums vector. So for int num in nums. Now we need to identify the digit sum of this element, right? So let's take a variable sum and initialize it to 0. And then we will take this number num in some temp variable, right? Now what we'll do is that we'll run a while loop, that while our temp is not equals to 0, in the sum we will add temp modulo 10, which will give us the last digit. And then we will do temp equals to temp divided by 10, right? So this will remove the last digit from this element. Now out of this while loop, we will have the sum of all the digits of the number in the variable sum. Now we need to check that if this sum is already present in the map or not. So we'll do mp dot find sum. If it is not equals to mp dot end, that means it is already present. So we will form a pair of this element with that particular element, right? So in the result, we can take the maximum of result, comma, num plus in MP, whatever is present at this particular key. right? And then out of this, we need to update the maximum value corresponding to this sum in the map, right? So in the map at the key sum, we will store the maximum of whatever is the current value, comma, this particular number, right? And at the end over here, we can just return our result. So let's run this. So here if you see, we are iterating once in our vector nums, right? So it will run n time, and inside this we are finding out the sum of the digits. And as I said that this will only run at max 10 times, so this can be considered constant, right? So here our time complexity will be order of n. And if we talk about the space complexity, so we have taken this unordered map where the key is the digit sum, right? Now the maximum number that is given to us is 10 to the power 9, right? Its digit sum will be 1 only. But if we consider the number just smaller than that, so it will be this particular number, right? If we do its sum, it will be, I think, 81, right? So then that means the maximum number of keys that you can have in the map MP can be 81, right? So our space complexity will be 81, which is constant. So we can consider that our space complexity is constant. So let's submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.